This next problem is simple division. So a shortcut, since these are both 2's, is you could actually subtract the exponents right away. 3 minus 2 is 1, so it becomes 2 to the first power. 4 minus 4 is 0, so that becomes c to the 0. And 2 minus 2 is 0, so that becomes t to the 0. 2 to the first power is 2. And anytime you have something to the 0 power, it equals 1. So since 2 times 1 is 2, our answer is just 2. Now, if you recognize that you have two bases, like here the c with the same exponent, right away, since you know that's going to be 0, you can cancel it out. But remember, it's an imaginary 1. It's not 0. So here this canceled as well. This next problem, it's going to combine several of the rules. So on top, we have a power of a power. So here we want to take care of that exponent first. So I'm going to leave the 2m squared on the outside. And then we're going to give everything in here this little 2. So it becomes 3 squared, m squared, I give it the 2, and the n, I give it the 2. The denominator, I'm going to leave how it is for now. And then I'm going to simplify this parentheses. So 3 squared is 9. And then 2 times 2 is 4. And then we have n squared. From here, the numerator is a multiplication problem. So I'm going to start with the coefficients. 2 times 9 is 18. I'm going to put imaginary 1 here. When you multiply, you add. So 1 plus 4 is 5. And 2 plus 2 is 4. On the denominator, we have 12m cubed n to the 4th. So if you remember from the last problem, here our n's are actually going to cancel because they equal 1. 18 over 12, we want to simplify that. It's not going to be a whole number, but you can divide both by 3. So it's going to become 6 over 4. We could have also divided these by 6. So let's divide by 6. And then it would become 3 over 2. So this is going to equal 3 over 2. And then for the m's, you would subtract the exponent. So 5 minus 3 is 2. So it becomes m squared. You could write it 3/2 m squared. Another way to write it would be 3m squared over 2. Either of those answers is correct.